Okay, right, yeah. So I'll just give you a quick tour of this observable platform, a new technology I've been using. But I'm doing this presentation in a new way. You'll see how it works. Hi, thanks for coming today. Today I'm going to talk about a new dataviz platform I'm very excited about called Observable. So Observable is a better tool for knowledge workers, and more broadly, I think it's a better tool for development in general. So why should you care? It's super cool in the industry right now. You might have heard of Alex Mordovintsev as the creator of Deep Dream, those crazy neural network hallucinations. He, in my opinion, is at the forefront of decoding and recoding insights extracted from modern machine learning architectures. He's a pioneer in the knowledge industry. And he says, and I quote, "Observable community is 1,000,000 times more creative and facilitated more interesting ideas than all of crypto combined. So if you want to explore ideas with computers, this is the place to be." So Observable, the company, strongly believes that extracting insight from data and communicating it is the #1 essential skill for the 21st century. Observable was founded by two big names in the industry, Melody McFessel, an engineering VP at Google. You sometimes hear her talk about using visualization to break analysis deadlocks on important algorithms such as search. It was also co-founded by Mike Bostock, the creator of D3, New York Times' digital superstar. He has a background working with journalists. The important thing is that they both believe in the power of visual summarization to make consequential decisions in the modern world. Both are united under the mission of, and I quote, "building a better computational medium." This very much chimes with using the computer as a bicycle for our minds, as Steve Jobs once said. And this is what originally got me into computers. But this is all very abstract. What is Observable exactly? Observable is a notebook authoring platform where a notebook is an interactive document, a bit like a Google Doc, but with sliders and interaction and things. Each notebook is made up of programmable cells like a spreadsheet. The underlying programming language is JavaScript, and the cells update only when they need to in a reactive way. Thus, a notebook is also a development environment. It's fully managed, and there are no tools to install on your laptop. It all works completely in the browser. It's not a proprietary representation either. Each notebook is also an ES6 module. And when you name a cell, it's really just an export. But Observable is not just about authoring. When you publish a notebook, it can go to a trending feed. People can comment and upvote each other's notebooks. So there's this social layer built on top. If you like someone else's notebook, you can customize it by forking it. And there are also features to embed notebooks in external websites. When you take all these features together, the Observable platform is a better way to code, explain, share, and discuss knowledge. One of the superpowers of Observable comes from having the code next to the documentation. This is not a new idea. It was pushed by luminary Donald Knuth, Turing Award winner, developer of text, and the author of The Art of Programming. The reason why literate programming is powerful is that by explaining code properly, you make it accessible to more readers, which allows more eyes on the code, leading to robustness and maintainability. So let's have a deeper look at a notebook. This one's by Rousseau, an aerospace engineer who enjoys making mathematical concepts more approachable. So this is what a notebook looks like. Ricky starts by giving us some pros to introduce the topic. If we click on the left, we can edit the underlying code for each cell. So the first cell is a markdown cell. It's expressed as a JavaScript template literal, which is very convenient for writing plain text. The second cell is a figure, and what we see is some embedded latex, which is great for writing maths. That latex is actually embedded inside a markdown cell, which is good for writing the text in the figure caption. And then that caption is actually embedded inside a HTML template, which is what actually makes the figure. So you can see that actually in the figure, it's calling out to a file attachment URL. So this is a feature of a notebook that allows you to embed static assets within a notebook. So here the embedded static asset is an image, but often people also use it for embedding data. So you can embed CSV files, for instance, within a notebook. So this is just awesome for technical writing. We can use different markup languages all together to produce beautiful documentation easily and even programmatically. If we continue on a bit, we see our first interactive visualization. So a little bit above the graphic, we see some code. And this code is a template literal for GLSL WebGL shader language for GPU stuff. And the output of the graphic is affected by the mouse, and it also has this little vanilla HTML control. And when I move the control, everything else is affected. So this is a good demonstration of the reactivity. I can interact with any of the dependents and it updates. And even I can interact with the source and it updates. So the data is reactive, the code is reactive. And this enables new ways of coding. I can position the parameters, and I can change the source code, and I can keep the source code fixed, and I can change the parameters, and I can pivot around data and code space really effortlessly without ever having to restart my program session. And this is really amazing for many types of coding. Now, if we scroll down a little bit to the bottom, we get to the point of the notebook, and that is a contouring algorithm, which will show you the contours of a mathematical function, regardless of how far you zoom in. So all this prose and chat has been building up to this application, and by the time you get to it, when you're reading it, you understand what's going on, and you realize that this is a great solution to quite a difficult problem for displaying mathematical functions. So also at the end, we have some vanilla JavaScript support utils, some CSS styling, and some imports. Note how you can import code from other notebooks. And the way it displays these is as hyperlinks. So what I really love about this platform is when you click these hyperlinks, you're taken to that dependency. But you don't land in a load of code. You land in a well-written piece of documentation thanks to this literate programming paradigm. This is just amazing. So if we take a step back, it's worth clarifying what makes Observable unique compared to some similar tools. So there also exists Jupyter notebooks, which are loved by the data science community. And there's a new startup, Replit, who distributes a web-based development environment. So it's worth saying, how is Observable different to these two products, which are superficially similar in some ways? So the big difference architecturally at a technical level is that Jupyter notebooks, while you are interacting with it within a browser, you are connecting to a remote Python process. So you're coding at a distance. And same with Replit, is it supports many different languages, but you interact with it through a browser, and you have some kind of remote connection to a Docker container, and that's where the action is actually happening, and you're just through this remote link, right? The big architectural difference with Observable is vanilla JavaScript, and it's executed inside your browser. So the code you author is run directly in the browser. So there's no indirection, there's no remoteness. And this means you don't sacrifice many of the production JavaScript development tools you already use. So what we can do is actually leverage the Chrome development tools as is. You can put in a debugger expression and jump out into the Chrome dev tools and debug functions like you would today in normal front-end development. So this is an environment that's not sort of hobbled by being remote in any way. The other major difference is this out-of-order reactive update. So in a Jupyter notebook, each cell has to be executed in order, and if you change code higher up, you have to rerun everything below. With Observable's reactive updates, the cells are executed in whatever order is necessary, and only a few cells are recomputed when something changes. And this is much better for iterative development, as you remove almost all unnecessary compiling or manual execution steps. And it's kind of hard to describe how this leads to such a productivity boost. You really have to learn it, learn how to exploit it efficiently, and then you'll see that this is just such a better way than the code run REPL loop. And REPLs were already pretty cool, but this is better. You are not locked in with Observable either. So when you start writing a notebook, by default it's private, and then when you're ready to share it, you get a public URL. But you can also embed these notebooks on third-party websites using an embed link. And what is very interesting to me is that a notebook is also an ES6 module, and you can actually write package.json for NPM in such a way as that it will fetch that ES6 module from Observable, and you can link these things into Node.js programs if you don't do anything web specific. So I have examples of this doing this, and it works. And you can save that ES6 module elsewhere, and it's yours. You have copyright on it. Another unique and special thing about Observable is the community. What I find interesting is that a significant proportion of Observable's community is not in the software industry. A large proportion are journalists or designers, engineers from other disciplines, people who are not necessarily optimizing software skills for its own sake. For me, it's very refreshing to see people using computers as merely as a tool for a higher purpose. The community is very supportive with each other. There's a forum. You can comment on each other's notebooks, and you get lots of comments with positive ideas of improvement. It's really great. The company has an explicit ethical direction around social justice and equality. Observable particularly thinks that data and information can help highlight gaps in society and can be used as an effective force for good. So I personally feel encouraged that by me supporting this company, it will indirectly help important causes. And sometimes they have special events which enable more direct activism, which I like to take part in. There have been a few successful dataviz graphics produced on the platform. So this viral tweet helped combat some of the political misrepresentation that was happening during the last US presidency. So it's quite a good example of presenting information in a way that tells a story and helps inform people better about their world. And this is the stated aim of the platform: helping everyone make sense of the world through data. It can do even more, though. As it's ultimately a general purpose web programming environment, it can do basically anything you could do on the front end. So this presentation, for example, is written in Observable, but it also supports creative coding very well. This is some incredible artworks produced by Macchio. You can also use it to develop software as a service applications. I wrote quite a popular tutorial on setting up Firebase and Stripe with the idea that with these tools you can have permanent state in a database, and you can also make payments using Stripe, and that all works on the platform. After writing the SAS tutorial, I thought, why am I coding JavaScript in Visual Studio Code for deployment in Firebase functions? Observable is JavaScript,
why do I need to switch environments to deploy a JavaScript Lambda, for instance? So my new baby is adding a serverless runtime environment to Observable. So with serverless cells, it's possible to write a HTTP handler right inside a notebook, and the notebook's code will be called when that endpoint is hit. I've been hacking intensely on this platform for a few months. I've been a member for a few years. My personal discoveries and revelations that I've had while doing it is that a fast development loop is the biggest productivity boost. It's bigger than types. And I come from an early adopter of TypeScript. I've been a Scala programmer for many years. I've been a huge enthusiast and proponent of types, but now I'm like, types are irrelevant. If you can just stay with the thread of execution and change the code on the fly, this is such a faster productivity boost than types ever were. And being able to mutate programs mid-flight enables much more intricate programming. I can do more complicated things than I used to be able to, because you can start offloading some of your mental visualization into the notebook. So if you add a few helper controls to help you visualize what's going on, then you can sort of program with that in place, and it saves a lot of mental effort. I have quite a good example of these intricate programming with a series of Kirigami experiments where you're programmatically folding pieces of paper. And in order to know what's going to happen to a piece of paper after it's been through n folds, you have to kind of sum up these kinematic transformations. And this is notoriously difficult. Like, it's very easy for a polarity mistake to creep in. So just by having the virtual piece of paper in the notebook and programming the kinematic graph in code and having these two things synchronized, I can do much more interesting Kirigami shapes than I would otherwise. The other revelation I've had is just how powerful the literate programming paradigm really is. I found it incredibly easy to understand other people's code in a way that I didn't have before. So you have like code which is great at expressing precisely formal knowledge, and then you have prose and diagrams which help explain qualitatively some knowledge. And when you combine these things, it's just so much better for understanding. And I've, as well as being incredibly productive on this environment of programming my own things, I've learned so many new things since being exposed to this platform, and I just enjoy reading other people's notebooks and learning about all these crazy things that exist in the world. So I'm just so in love with this platform. I hope you give it a try and have a look.
Okay, thank you. Is there any questions?
Thank you, Tom. That was really, really nice. Does anybody have any questions or comments or things that you want to say out loud?
Maybe like one thing, if I was, for example, to write like a basic dev blog post kind of thing that one would maybe write in Medium or dev platforms, is there like a learning curve in Observable compared to those?
So some people do use it to write their own blog, and then, but a limitation then is you're putting your blog on their domain, and then there's discoverability things. And also, in some ways, it's not as good as Medium, because although you can do these markdown blocks, writing it's okay, but there's no spell checker. So that's a pain. I've asked them to add that feature. But you know, and also when you go to a website, it takes a few seconds to load, so it's not as snappy as I would hope like a dedicated blog technology would be. That said, because I'm developing these serverless cells things, I did actually write an integration with Netlify, so you can actually dynamically generate the HTML you want to deploy, and then it will read that and do a static site deployment of that dynamic content. So there are workarounds, and you can extract it out of the site. And so my personal blog is written in Observable, but deployed on Netlify as a static site. And so that's basically, we've solved all the issues at that point, and it's awesome.
Yeah, and because like the first use case I could imagine for myself would be to write some sort of technical blog post kind of thing with some like interactivity kind of stuff where this would shine, obviously. But yeah, good to hear.